Hello grade 11s, let's look at another video on the electrical circuits. So the question says, consider the circuit diagram below. The internal resistance of the battery and any resistance in the wires can be ignored. So they're talking about ignoring the internal resistance of the battery and any other resistance in the wires. We can be able to ignore those. So you need to be careful of that information, guys. And then all right, so the next step that we're going to look at, we look at the battery. So looking at the battery there, we have got two configurations of the battery. You have the positive terminal of the battery and also the negative terminal of the battery. So this is the positive one, and the other one, that side, is going to be the negative terminal of the battery. All right, so from here, we are going to look at how current flows so that we can be able to determine which resistors are connected in parallel and which ones are connected in your series. And then the other thing, just to remind yourself, guys, you remember that current flowing across a parallel circuit is divided, and current flowing in the series circuit is going to be the same throughout the flow of that current. And then number two, potential difference is only the same in the parallel circuit. And from there, we're going to look at your potential difference being divided or shared across the series circuit. And resistance, when you opt for your circuit to be connected in a series circuit, basically, so you know that you're basically increasing your resistance because you're basically going to add if you're looking for the total resistance of the circuit. And then number two, in a parallel circuit, we know that a parallel circuit basically reduces the degree of resistance there. Okay, so our current is flowing clockwise, flowing through this way. So the current gets to be shared when it gets here. The other one is going this side, and the other one is flowing into this resistor. And the very same current flowing this side is going to flow through this one. The very same current will also flow through this one. And then all this current will meet at this point, and then it goes back to the battery there. Okay, so thank you so much. And then as a result, guys, we are going to look at this one, and also the R there to be connected in series. And because they are connected in series, guys, it means we can be able to add them so that we've got a unit of a resistor there. So 3R plus 2R plus R equals to it's going to be your 6R. So it means now the new circuit after adding 1, 2, 3 is going to look this way. We're going to say this one is going to be the 4R, right? And then from there, the next one that is going to be the 6R is going to be this one. All right. So now, in other words, now, therefore, it means 4R and the 6R, guys, are connected in parallel. And then they're connected in parallel. It means they have the same potential difference. They share the amount of current throughout there. But however, in the 6, you remember in the 6, we basically combined your R, we combined your 2R, we also combined the 3R. So the amount of current flowing this side, and also this side is going to be the same. And the voltage flowing this side, and also this side, it's going to amount to the same voltage that is basically flowing in the 4R there, because 4R, it's connected in parallel with the combination of R, 2R, and also your 3R there. So that's basically how we're going to analyze that circuit. And okay, so I'm just going to erase so that we can be able to have space there. All right, thank you so much. So let's continue. I want us to look at the first question there, and we analyze the questions. Calculate the value of a resistor R if the total resistance of the circuit is going to be 4.8. Guys, they want us to calculate the resistance, actually the value of R, because remember, for example, for R here, it is the resistor, but the R is basically the unknown variable there. So we need to make sure that we calculate R. That is common throughout your 4R, your R, your 2R, and also your 3R there. So now let's see how we're going to figure that out, because we are just given the total resistance of, the circuit there. If the total resistance of the circuit is 4.8, guys, then we know that, for example, we said after computing this, we're going to have, this one as your 4R, and we're going to have your 6R there. So how did we get the 6R? We said R plus 2R plus your 3R equals to your 6R. So therefore, we used that because they're connected in series to get the total resistance across the series circuit of that. So now, guys, the 4R and the 6R are connected in parallel. We're going to try to write the formula that represents this parallel connection. We can have them as your RP equals to R1 times R2 over R1 plus your R2. So what is going to be your RP there? We're going to substitute RP as 4.8, right? Because that is basically the total resistance of the circuit. And then we're going to have your R1, I'm going to choose to be 4R multiplied by your 6R all over 4R plus your 6R. I'm just taking advantage of the mathematical principles in order to calculate what we are looking for there. It's a very simple question. You just have to be mathematically inclined there. All right, guys. So you're just going to have your 4.8 equals to 4R times 6R. We know 4 multiplied by 6 is going to be 24. Then I'm going to have 24R squared all over 4R plus that is going to be 10R. All right. So we have got, basically we have 4.8 equals to 24R squared over your 10R. So guys, we don't have to complicate this thing. So R will divide into that, and then 4.8, and then at the same time we cross multiply. 4.8 times 10, 4.8 multiplied by 10 is going to be 48. We're going to have 48 equals to 24R. So we divide both sides by 24, and then also this side we divide by 24. So your R equals to 48 over 24 is going to be 2 ohms. So the value of R basically is going to be your 24 ohms, guys. Very simple. Can we just quickly recall what we did? The first thing was to determine the direction of the conventional current, and we found that the current is flowing in the clockwise direction. Then we realized that 3R, 2R, and your R there, the current flowing there is the same, so we just added them. And then after adding them, then we just going to say the 6R there that resulted is in parallel with the 4R. And then we took advantage of the parallel connection formula. We said RP equals to R1 times R2 over R1 plus R2. And then from there, we landed to R equals to 2 ohms there. I believe that that is basically the simplest question that, one can have to answer there. All right, thank you so much. Let's go to number 2. I'm going to erase this information, guys. Number 2 says calculate the reading on the voltmeter if the current through the 4 ohm resistor is 1.8. Calculate the reading on the voltmeter. All right, let me check. Remember, from the previous information, we calculated that your R equals to 2 ohms. Thank you. All right, after calculating that, now the question says calculate the reading on the voltmeter if the current through the 4 ohm resistor, the current through the 4 ohm resistor this side, it's going to be your 1.8. You have 1.8 amperes flowing there. Guys, remember, if you've got 1.8 of current flowing there, we can just take advantage of the potential difference this side, we're going to say V equals to IR, and then we're going to have I as 1.8 multiplied by, remember this side, the resistance is 4 multiplied by the 2 that we got from this side, and then 1.8 multiplied by 4 times 2 is basically going to be it's going to be 14.4. So we're going to get 14.4 V. We can write it as your equal sign 14.4 V there. All right, so okay, then from here we must look at what we can always do with this information that we got there. We said V equals to IR, and then 4 times R, which is 2, it's 8. 1.8 multiplied by 8 is going to be 14.4 V. All right. Now, this is the potential difference flowing across this parallel circuit. And this very same 14.4 V, we should know that it is the amount that is flowing in this one, and this one combined as your 6R. So it means we can take advantage of the 6R and together with this one to get the amount of current that is flowing throughout this. And from there, understanding the amount of current flowing there, we can be able to understand the voltage that is flowing in that segment. All right. Or we can always go back to grade 10 and take advantage of the ratios. If we know that in this one and this one, and the R resistor there is 14.4 volts of current flowing. Therefore, we can do this. We can say, guys, okay, so this one here, we're going to have a 2. 2 times 2, you're going to have a 4. And then this one, 3 times 2, you're going to have a 6. Now, we're going to say 2 plus 4 plus 6 is what? It's 12. So the total resistance there is 12. And then if we want to understand the amount of voltage flowing in the 2R, we are just going to say 4 over the 12 multiplied by the 14.4 that is flowing across the other segment of the parallel circuit. So we're going to have 4 over a 12 multiplied by 14.4. All right, so we're going to have your 4.8 of voltage that is flowing in the 2R resistor. Oh, that's correct. Okay. Yes. And then from there, you can also do this if you want to make sure that your calculations are right. You can look at the one that is flowing in this one as your 2 over 12 multiplied by 14.4. Guys, remember, we are taking advantage of the grade 10 method. 2 over a 12 multiplied by 14.4, it's going to be 2.4. We've got 2.4 volts. Then the one flowing in the 6 is going to be 6 over 12 multiplied by 14.4, it should be 7.2. So 6 divided by 12 multiplied by 14.4, it's going to be 7.2 volts. So if you add 1, 2, 3, they should give you the total of the 14 there. Let's add them and see if we can get that. 4.8 plus 2.4 plus 7.2, guys, is going to give us the 14.4. And then mind you that, you know, the answer they're looking for, it's going to be the 4.8 of volts there. Wow. And they gave us the current flowing in the 4R resistor there. And then we calculated and we found that to be, the current is 1.8 and then the voltage there is 14.4. I'm just trying to quickly look for the next method that we can be able to use in order to get to the next calculation there. All right, so okay, it's fine. Then let's look at what we can do. 12.3 says calculate the energy converted in resistor 4R in 2 minutes. Guys, there are different formulas to calculating the energy. So this one, you just have to look at your formula sheet and make sure that you master the formulas that are there. I know that energy could be VI, change in time. Energy could be I squared R, change in time. Energy could be V squared over R, change in time. All right, so now we need to go to the 4R resistor and we understand the information that is given there, guys. We know that on the 4R resistor, we know the total resistance, there's going to be 4 times 2, that is going to be the 8. And then where did we get the 2? 2 is the value of R there that we calculated in 12.1. And then the current flowing there, they told us on the previous question that it's 1.8 of your amperes, and the time is going to be 2 minutes. Guys, how many seconds are there in 2 minutes? We know there's 60 seconds in 1 minute. So it means in 2 minutes, you're going to have your 120 seconds there. So you must choose the formula that contains the resistance and also the current. It's going to be formula number 3. So we can have that as W equals to I squared. You must always rewrite the formulas. And then your I is going to be 1.8 square multiplied by your 8 into 120 of seconds there. So 1.8, therefore we subject everything to our calculator, multiplied by an 8 into 120. Then we get the energy there to be 3110.4 of joules there. So energy is measured in joules, guys. I think this is simple. You just have to make sure that you understand the given variables, understand the information that is given, and also what the examiner is trying to say. All right, thank you so much. And then from here, let's continue. The 4R resistor is replaced with an ammeter. Wow, can we go to the 4R resistor? It is now replaced with an ammeter. The 4R resistor is replaced with an ammeter. What is it that we know, guys, about ammeters? We know that ammeter is basically an electrical device that measures the current there. And then now, if we take out the 4R resistor and replace it there with an ammeter, so it means the current will only flow in the 3R, in the 2R, and also the R resistor there, because it means we are trying to change the configurations of the circuit. It means we're no longer going to experience your parallel circuit there. We're only going to have a series circuit that flows just like this. All right, so how will the reading on the voltmeter be influenced? Right only increases, decreases, or stay the same? All right, I'm telling you, we need to apply the Ohm's law here. Right, look now. We are going to say now, we go back. We are going to look at the total resistance of the circuit. From 12.1, the total resistance of the circuit is 4.8, guys, ohms. And then having the total resistance of 4.8 ohms. Therefore, we are going to look at the new total resistance of the circuit after taking out the 4R. So it means we are going to have, remember this is 2. This one is going to be 2 times 2 is 4. This one is going to be a 6. So it means we're going to have 2 plus 4 plus 6 equals to the 12 ohms there. All right. So it means we're going to have your 12 ohm resistance as the total. So it means we're moving from a 4.8 to a 12 ohm resistance. So we are basically increasing. It says, how will the reading on the voltmeter be influenced? Right only increases, decrease, or stay the same. Guys, let's start by stating Ohm's law. We know Ohm's law says the potential difference across a conductor is directly proportional to the current flowing in the conductor, provided temperature remains constant. So now, we know that R is basically equals to V over I. R equals to V over I as your formula there. Is like that's Ohm's law. It's V over I, and therefore we know that when resistance increases, the current will drop. So as the current is dropping, guys, it means the potential difference is also decreasing. So it means we're going to have a decrease as an answer there. Explain the answer to 12.4, that's 12.5. Explain the answer why we're saying it's going to decrease. So guys, this is what we're going to do. We're going to say a series circuit increases resistance. Series circuit will increase the resistance. And therefore, that's number one. Point number two, resistance is inversely proportional to the current. So when the resistance increases, the total current will decrease. And according to R equals to V over I, when current decreases, the potential difference also will decrease there. Thank you so much. Just don't forget to subscribe with us and reach us if you are looking for any information. Thank you so much. Bye-bye.